The molecular dipole is the sum of all the dipole moments in a compound. And so the dipole moments you can figure out by looking at the relative electronegativity of two atoms in a bond. And so the more electronegative element, like the one on top, is going to have a partial negative charge. It's going to suck the electron density toward itself, and that's why you get this arrow right here going toward the more electronegative element. And since you have another carbon-chlorine bond down here, there's another arrow showing this chlorine, which is still more electronegative than the carbon, sucking electron density toward itself. So we usually just look at the individual dipole or the individual polarities of bonds in a molecule when we're figuring out like intermolecular forces and other features of the molecule. But occasionally it's helpful, or at least you're asked about the molecular dipole moment. And the molecular dipole moment is the sum of those individual little arrows that are shown here. If you haven't done any like vector addition before, then it can be a little confusing to try to figure out how to add vectors or arrows together. And let's see if I can find, where are my, I need a pen there. All right. So the way that I like to think about it is when we're adding vectors together, which is what these are, arrows and then the size of the arrow. I like to think about like like walking. And so if I walked forward, like this arrow shows me, so here I am, I'm walking forward, kind of. It's my best ability to do that. And then I turn and I walk this direction, back a little bit where I come. The question is, what is the total displacement? Like, what's my distance and direction from the beginning? And it's from the beginning of one arrow to the head of the other, like that. So that would be my overall, that would be the sum of the vectors, and that's what's shown here. So that's how the vectors down, or the dipole down here are given, is that there are multiple polarity arrows, and then when you add them together, sort of the movement to the sides is all canceled out. But in overall, you get this straight ahead, forward, up net dipole moment. So that's where that comes from.